So we will discuss on how to find the centroid or how to locate the centroid of composite sections. So some certain points you have to remember when you are finding the centroid of composite sections. So the thing is, the steps are like this. First you have to split the given composite section into simple sections. Simple sections means rectangle, triangle, circle, semicircle like that, whose areas and centroids are known. Then after that we have to use you have to fix some reference axis, x-axis and y-axis, because you need two coordinates to define the position of a centroid. So we have to use two different axes of reference, x and y axis like this. So the horizontal distances are measured from the y axis, vertical distances are measured from the x axis. So it is something like this. You have a given composite section, it is split into so many simple sections like this, and these simple sections you can always locate the centroids of these simple sections, and the distances of those simple sections from the axis of reference you can easily note. So for example, this is the first section, distance horizontal distance from the y-axis is x1, and for the second one the horizontal distance is x2 like that, and similarly x3, x4 like that, and vertical distances from the x-axis you can take it as y1, y2 like that, y3, y4 like that. It is measured from the x-axis. So these things you can easily locate because these are known sections. So maybe one may be a rectangle, two may be a circle, three may be a semicircle like that. So you know the formula to find the location of those simple sections. Once you get that, then this is 3, 4 like that. Areas also you need to calculate. A1, A2, A3, they are the corresponding areas of the simple sections. So distances x1, x2, x3, y1, y2, y3, etc. they should be known. Areas A1, A2, A3 they should be known. Then you can locate, you can find out the centroid of this composite section. Let us say if it is D for this entire section, the centroid lies here. Then this becomes your x bar from the y-axis. Whatever distance to D is there, that is x bar, and from x-axis whatever distance is there to D, that is y bar. So these two are found out using the formula x bar is equal to summation ai xi divided by summation ai. That means here instead of using integral formula we are using discrete formula. So discrete formula summation ai xi means it is a1 x1 plus a2 x2 plus a3 x3 etc. divided by summation ai means it is a1 plus a2 plus a3 etc. like this. So total area you get. Similarly, y1 is given by summation ai yi divided by summation ai. Here also it is a1 y1 plus a2 y2 plus a3 y3 etc. divided by a1 plus a2 plus a3 etc. So like this. So using these two formulae, discrete formulae, you can find out, you can locate the centroid of the composite section. So the thing is, you need to know a1, a2, a3 etc., x1, x2, x3 etc., y1, y2, y3 etc. with respect to the particular defined reference axis. So once again, the axis you can define based on the given problem. So sometimes they may give symmetrical figures, composite section symmetrical about one of the axis. So in that case, some certain rules, rules we have to follow. So the first one is always the centroid lies, D lies on the axis of symmetry. On the axis of symmetry, this is one point. So suppose if the given figure is symmetrical about y-axis, centroid lies on y-axis. If it is symmetrical about x-axis, its centroid lies on x-axis. So that is one point. Second point is, suppose if you have any cutout portion, if there is a hole, let us say if there is any hole portion or cutout portion in the composite section given, then the area of that cutout portion is taken as negative. Area is taken as negative. That means when you are taking the sum, the area of that particular cutout portion is taken as negative, and then we are going to get the total area. So that is another thing. Then the third one is when you are finding this x1, x2, x3, that is the location of the centroid from the y-axis. Centroids of the simple sections from the y-axis, x1, x2, x3, those things. The sign convention we have to follow is, suppose if this is x-axis, this is y-axis. If you are finding x1, x2, x3, if the portion lies, if the centroid lies to the right of y-axis, then x distance is taken as positive. If centroid lies to the left of y-axis, then x distance is taken as negative. So this is another sign convention we have to use. So x1, x2, x3 can be either positive or negative, depending on the position of that centroid from the y-axis. Similarly, for finding y1, y2, y3, vertical distances of those centroids from the x-axis. Yes, so from the x-axis, if you are finding the distance, suppose if it is above x-axis, then this distance y is taken as positive. If it is below x-axis, over here, the distance is taken as negative. Y is taken as negative. So these are the sign conventions we have to use for finding the distances x1, x2, x3, y1, y2, y3, etc. And for finding the areas, if it's a cutout portion, area is taken as negative. So for example, I will give an example here. See, this is x-axis, this is y-axis. Origin is here. Let us say you are finding the centroid of something like this. This is a rectangle, and you have a circular portion cut out. So this is a hole actually. So only you have to find out you have to locate the centroid of only this portion, shaded area. So this is a whole portion. So this area you have to take negative. That is one thing. And whatever centroid lies, if centroid lies to the right of y-axis, x distance is positive. If centroid lies to the left of y-axis, x distance is negative. So all those things we have to keep it in mind. So mainly three things are important. First step, we have to divide the given composite section into simple sections whose areas are known, whose centroids can be located. Second, you have to find out the areas of those simple sections. If the area is a cutout portion or a whole portion, that area should be taken as negative. Next, third point is when you are finding the distances of the centroids of those simple sections with respect to x and y axis. So if the centroid lies to the right of y axis, then x is positive, left of y axis x is negative. If the centroid lies above x axis, y is positive, below x axis, y is negative. So these are the rules we have to follow. Once you get those values here in this, a can be positive or negative, x can be positive or negative, y can be positive or negative. So once you know all those values, then you can use these two formulae to find out the location of the centroid of the composite section G from the y-axis and x-axis. So these are the general guidelines to find to locate the centroid of a composite section. Now let us solve this problem now. Here this is an I section. This is an I section whose dimensions are given. So all the dimensions you can take it in millimeters. So all the dimensions are in millimeters. Now the question is determine or locate the centroid of this I section. So if you observe this, this is symmetrical about y-axis. So you can take this axis as, if you draw a vertical line here, so you can see left of this y-axis is similar to, is identical with the right of this y-axis, and I will take this bottommost adjust the x-axis. So usually the procedure is bottommost edge is taken as the x-axis, leftmost edge is taken as the y-axis if the given section is not symmetrical about any of the axes. Of course, in this case, it is symmetrical about y-axis, so therefore I can take y-axis here at the center line of this center of this line of this I can take it as y axis. So in this case, we can say that the center of centroid of this I section lies on y axis, because the reason is it is the axis of symmetry. Therefore, it should lie on y axis. So it is definitely only one thing we have to find out, that y bar we have to find out here. You need not find out x bar because it is symmetrical about y axis. So only centroid it will lie near to the area, or near to the region where the area is concentrated more, where the area is more. Suppose if you observe this, the general thing is here the area is less, 100 by 20, whereas here it is 150 by 30. The area is more concentrated towards the bottom of this I section. Therefore, centroid also will be close to the bottom of the I section or bottom edge. So somewhere here it will not be exactly at the center of the I section. It will not be exactly at the geometrical center of the I section, because it is not symmetrical about x axis. It is symmetrical about only y axis. Therefore, only thing is you can say that centroid lies near to the bottom edge of this I section, because more area is concentrated at the bottom of this I section. Now, if I take this as x axis, naturally d is somewhere here. This is your y bar. So y bar is the distance of the centroid from the x axis. So this you need to find. So only this formula we have to use in this problem. X bar you need not calculate, because the centroid lies on y axis. So x bar is 0. In other words, you can say x bar is 0 because it lies on the y axis itself. Now the procedure is like this. First of all, we have to divide this into simple sections. Simple sections means here I section consists of 3 rectangular sections. You can see here, first rectangle 100 by 20, second rectangle you can take it as 100 by 20, third rectangle 150 by 30. So let us solve this problem by drawing a table. So in the form of a table, let me try to use a table, because it will be easy for you to understand. So what I will do here is I will draw a table where we can write all the areas and x distances, y distances, all those things. Later on we can find out x bar and y bar. Of course here x bar you need not find, only y bar. So the table looks like this. First I will take serial number. There are 3 rectangles here. So here the second is I will take the figure of the lamina. Third one is area, corresponding area in millimeter square. I will write the units. So this area actually is nothing but AI. Then x distance, or I will write xi, which is measured from y axis. Then y distance, yi, so which is measured from x axis. Then you have the product ai xi. So which will be in millimeter cube, because area is in millimeter square, xi is in millimeter cube, it will become. Then ai, yi, that is also in millimeter cube. So now, these are the items we require. So serial number 1, I will divide this given I section into 3 rectangles. This is rectangle 1, rectangle 2, rectangle 3. Okay, so rectangle 1. So figure is rectangle 1. So I will take rectangle 1. Area of the rectangle 1 I will write 100 into 20. So this is rectangle 1. 100 into 20, 2000 it becomes. Okay, 2000 millimeter square. Then xi. Now you should be careful. Xi is the distance of the centroid of this first rectangle. Centroid of the first rectangle from the y-axis. But actually, since it lies on y-axis itself, I will take this as G1. The centroid of this as G2. Centroid of this as G3. So how you can see that since all the rectangles are symmetrical about the y-axis, you don't have any value for xi here. So this xi you need not write down because it is 0 here. xi is this g1 lies on this axis of symmetry centered on this. So you can take xi as 0. These two columns you need not write here, okay, because it is symmetrical about y-axis. Xi values will be zeros. Only yi I require. So please understand here, yi. So for the first rectangle, this is the centroid. Distance from x-axis to this centroid. This is the first rectangle one. From this x-axis to this g1, what is the vertical distance? That is your yi value for the first rectangle. So you can see here this is 30 plus 100, 130 plus out of 20, half of that is 10. So 130 plus 10, 140. So 140 mm is the distance. Okay. First let me write all the distances. This is rectangle 1, then rectangle 2. Second one is rectangle 2. So rectangle 2 is the portion, that is this portion. This I have taken as 2. Area of this will be 100 into 10 or 100 into 20 or 20 into 100, 15 into depth. This is also 2000 millimeter square. And here also, since this G2 lies on y-axis itself, distance of G2 from y-axis is 0. So xi value is 0. yi I have to measure from this x-axis. So from this x-axis, distance to this G2 will be 30 plus half of this 100. So 30, because the centroid will be exactly at the center of this 100. So 30 plus 50, 80 mm. Y value will be 80. So that is the second one. Now the third one I will take it as rectangle 3. Rectangle 3. For rectangle 3, this is rectangle 3. 150 by 30 is the area. So all areas are positive. There is no cutout portion here. 4,500. 4,500. Distance of G3 from x-axis is half of this 30. That is 15. 15. So that is your y value. Now only three simple sections are there here. Now we can find out the products. Once you write a values and x and y values, now you can take the product ai xi. Here ai xi term is not there. There is no product for that. So because all xi are zeros, so this also becomes 0. Only ai yi need. So 2000 into 140 ai yi. So 2000 into 140 is 28 followed by 4 zeros. 1, 2, 3, 4. Okay, 2,80,000. Then 2000 followed by 80. 16 followed by 4 zeros. So 1,60,000. Then 4,500 into 15. So 4,500 into 15. So the value is 67,500. Now we have to add. So please note that none of the areas are negative because there is no cutout portion or whole portion in this given problem. I section consists of 3 solid rectangular sections. So add all of this, you get sigma ai yi. Sigma ai yi is, you just add all the 3. So you will get 507500. 507500. So 5,07,500. So now this area also we have to add to get sigma ai. Sigma ai 2000, 4,000 plus 4,500, 11,000. Sorry, 8,500 millimeter square. This is millimeter cube. Now to find y bar, directly you can use this formula. Y bar is equal to summation ai yi divided by summation ai. X bar is not required. X bar is 0 here because centroid lies on y axis. So just substitute and simplify. 507,500 divided by 8,500. So you will be getting the answer as 5075 divided by 85. So 59.71706 millimeter. So the value is in millimeter because this is in millimeter cube, this is in millimeter square, area is in millimeter square. moment of the area is in millimeter cube. So 59.706. So that is the location, the distance of the centroid of this composite section from the base. Because I have taken x-axis as the base, so this distance is 59. So that is y bar distance is 59.706 mm. So in this problem, it is symmetrical about y-axis. Therefore, x bar will be 0. Only y bar we have to find out, and there is no cutout portion or whole portion here, so area is not negative here. And another thing is here there is no question of all the distances are measured from the above y-axis, therefore all the y's are positive only. So please note that if the centroids of the simple sections they lie right side of y-axis, x is positive, left side of y-axis, y is negative, above x-axis y is positive, below x-axis y is negative. Of course, in this problem, all the y distances are above x-axis. So g1, g2, g3 they are above x-axis. That's why y values are all positive, and there is no cutout portion. Therefore, all the areas are positive. So since the given I section is symmetrical about y-axis, x bar is 0. Only y bar we have to find out.